in the electrical system. And we can compare this system as we have seen the analogy exactly in the same way we have done it for electrical system. So this is the first element. See now if the flow is turbulent or laminar, we can, if we consider the laminar flow, Reynolds number is less than 200. The relationship between the steady state flow rate and steady state head at the level of restriction is given by this one, here. The level of restriction or resistance, a Q will be simply, a Q will be K laminar times H. Q will be K laminar times H, and we need to find what will be the expression of R. For the resistance, what will be the expression for it? R will be equal to what? So here, if you see that Q is the steady state, flow, is the steady state liquid in meter cubed per second. KL is constant and is meter square per second, and H is the steady state. We can write R as defined. You remember, we defined R, our resistance. What was the definition for our resistance in the previous slide? We defined it as the change in level difference over the change in flow rate. So if we write R simply as dH, the change in level difference over the change in flow rate over dq, we can say this one will be هنا Q over or H over Q if you want, H over Q from here. What will be H over Q, شباب? H over Q. What will be H over Q equal to what? From this relation, H over Q will be what, شباب? هنا resistor. H over Q will be what? Will be equal to what? 1 over KL. 1 over KL from this relation. Yeah, 1 over KL, that's right. Exactly the same. So if you take dH over the Q, it will be also 1 over KL, which is H over Q. Simply this one. So for laminar flow, the resistance is given by RL, which is H over Q. If you take dH over dQ, it will be 1 over KL, the same thing. So the laminar flow in resistance is constant, and it is analogous to the resistance in electrical systems, where we are writing the height play the role of the voltage is exactly the same as the voltage, and the steady state flow rate is exactly like the current. So R will be H over Q, which is analogous to R will be V over I, which is the Ohm's law. If you remember Ohm's law, it is exactly the same. H is the voltage, plays the roles of the voltage, and Q plays the role of the current, I. So Q flow rate exactly as the current, and H is exactly as the voltage. Khabbaz, okay, go ahead. تفضل.
Why did we consider H as a constant?
It's not why, because it's like this. If you look here, R is given by H over Q. If you compare this one, R, if you compare this expression, just comparison, when you compare this to the electrical system, you will see that R in electrical system represent R in liquid level system. And H in liquid level system represent the voltage. And I in the electrical system represent the Q. This is just a constatation. If you compare, this is what you will find. Is it clear, Shabab? In a similar way, we can find that the resistance in a laminar flow, the turbulent flow is simply this relation. Q is equal to KT square root of H. Q is equal, this is for turbulent flow. In turbulent flow, we can also write the equation in the similar. Khabbaz, is my explanation clear to you?
Yes, clear.
So just comparing the two relations, you will find this. R is equal to H over Q. Compare this. Compare it with Ohm's law. R is equal to E over I. You will see the voltage is equal to the H is compared to H. And the current is compared to Q. And R is R. Resistance is R resistance. This is for laminar flow. For turbulent flow, Q is given by KT square root of H. KT square root of H. And if you draw the relationship between KT and H, this is what you will find. You know, it's a little bit confusing what it is drawn here. The relationship between this one, if you draw here, this is head in the y-axis and the flow rate in the x-axis. If you inverse this, if you inverse it like this, in the here you draw the head H, and here you draw the flow rate Q, you will find that this relationship will be like this: KT square root of KH. This is here. You should, it will give you this relation is H is equal to Q square over KT square. But here, this is what it is given to you. It's the same thing. Either you look at it this way or this way, you end up by having the same result. So QT is given by Q is given by KT square root of H. Here you remember we defined the resistance to be the change in level difference over the change in the flow rate. If you take now dH over dQ from here, if you differentiate dH over dQ, so you will say dQ will be over dH, dQ over dH will be equal. If you differentiate this relation with respect to H, or dQ over dH, so it will be KT over square root of H, KT square root of 2H. If you look at this one, this is only, here it's given by the relationship. You can